Example 5, finding the x-intercepts of a polynomial function using a graph. We want to find the x-intercepts of h of x, which is equal to x cubed plus 4x squared plus x minus 6. Before we go any further, let's go ahead and try what we would have done in our previous examples. We have x cubed plus 4x squared plus x minus 6. Okay, now if we wanted to factor this by grouping, since we have 4 terms, we can factor out an x squared of the first 2 terms, and what we're left with is x plus 4, which means we should get the same thing on this side. But if you take a look up here, there's no way that we can end up with x plus 4. So we're not able to factor this in the techniques that we used earlier. Okay, so now what we want to do is we're going to have to then graph this, either using Desmos or a graphing calculator. So as stated, this polynomial is not in factored form, has no common factors that we can factor out, and again, it does not appear to be factorable using any of the techniques that we previously discussed. Now, fortunately, again, we can use graphing or technology to find the intercepts. Now, keep in mind that some values make graphing difficult by hand. In these cases, we can take advantage of graphing utilities. So, first thing we want to do is we want to look at the graph of this function, okay, and we want to see where it crosses the x-axis to find the x-intercepts. So, if we look here, we have an x-intercept at -3. So we have an x-intercept at -3, and then we have another one at -2, and we have another one at +1. Now, what we want to do is, now that we know what our x-intercepts are, okay, make sure we highlight that. So now that we know what our x-intercepts are, what we're going to do is we're going to set each of them as it would look like if we were solving for x-intercepts algebraically. So this would be the last piece of finding the x-intercepts. So we would say that x is equal to -3, or x is equal to -2, or x is equal to 1. And now what we're going to do is we're going to set each of these equal to 0. And in order to do that, we're going to add 3 to the left side, we're going to add 2 to the left side, and we're going to subtract 1 to the left side. And so in step 2, what we're going to end up with is x plus 3 equals 0, or x plus 2 equals 0, or x minus 1 equals 0. Okay, now, again, kind of going in the opposite direction of how we would find x-intercepts, well, what would this look like before getting to this result? Well, we would write this in factored form. And by writing it in factored form, it would be x plus 3 times x plus 2 times x minus 1, and that's equal to 0. So now we can write this in terms of a function. We can say that h of x is going to equal x plus 3 times x plus 2 times x minus 1, again, getting that information from the graph. And now each x-intercept corresponds to a 0 of the polynomial function, and each 0 yields a factor. So we can now write the polynomial in factored form. So the original form was h of x is equal to x cubed plus 4x squared plus x minus 6. But now writing this in factored form, it's x plus 3 times x plus 2 times x minus 1 from what we solved in step number 4. So again, imagine yourself, this is what you're given. You're given this form. And then you would set it equal to 0, and then use the 0 product rule to get this results. So you're kind of working backwards to find out what it would look like in factored form from the previously discussed exercises.